Hey, I am currently watching the NASA Curiosity landing, and this is just to record my reaction. I'm not sure how I'm going to react, though I know I'll be happy if it makes it. So here's live recording. And yes, you can hear that in the background.
The expected warnings for the Electra.
Distance 3,400 miles.
Copy. The EL team is running some final simulations to show where we can.
Via simulation, by the way.
Things continue to look good. Puts us right in the middle of the list. Each flight, we can confirm the BCB actions have been commanded, and through EHA, we confirm that the discharge beds are now in manual discharge. Vehicle copy. Power changes.
Turning up the volume.
It's going to cut loose the cruise stage and all that solar array that's been powering us.
I don't know how well you can hear it, but
Pyro firing cards are now powered on. Go ahead, EDL com. So we're ready to switch the displays over to the 1010 marker, which will show EDL data, manual tones. You ready? Standby 1. Yes, we are ready.
3,221 miles.
And we can confirm through EHA now that the BCBs are in manual charge mode.
Velocity 11,500 kilometers per hour. Miles per hour.
BCBs in manual charge. We've also completed enabling the pyros command.
So roughly 25,000 kilometers per hour.
Powering off the cruise stage hardware.
Roughly 2,000 kilometers per hour.
And we can verify through telemetry that the cruise stage hardware is powering off. Yeah, the cruise stage is turned off. Flight pyro buses on. Copy, thank you, Pyro. And enabled. Power electronics that are used to activate many of the devices that are going to be used to cut the cruise stage, and a lot of the separation events during EDL has been armed. Nav is confirming that we are starting venting. HRS vent has started. And flight EDL.
By the way,
first pyros,
this live is 14 minutes slow because the time from Mars to Earth to get the signal here is 14 minutes.
That heat rejection system is actually pushing the vehicle a little bit.
So what they're seeing now is 14 minutes slow.
Odyssey Com, Odyssey Mission Manager on EDL Ops.
What time is it? Alright, it's 2:13 in the afternoon here in Japan.
EDL.com, this is Dynamics on EDL Ops. Go Dynamics. Is our display configured correctly for you?
Alright, supposedly it's going to land
I see it. Waiting for it.
fairly soon.
Very nice picture.
And if that's the case, then what they're receiving is just
Under 2 minutes from cruise stage separation.
that's too far to actually see what's happening live. So we're just a few minutes late, but what can you do?
Odyssey has completed its salute of the EDL.com attitude. All systems are nominal. Odyssey is go for EDL.com support. Great to hear from you. Thank you very much. We have a cruise stage step about to happen.
Everybody's using apples.
We will have their coverage. Things are looking good for them.
I myself use a PC.
For us. We're about 1 minute to cruise stage separation. We're seeing the transition to tones now. The system should be configured shortly. And we're seeing carrier only. Vehicle's changing to tones at this time. So we're switching from telemetry to lost telemetry, and we're going to move to just tones. So position. And receiving heartbeats. We are receiving heartbeat tones this time. Affirmative, we're seeing the expected 2 seconds of heartbeat, followed by the 10-second carrier pulse. NASA can't see something that could be consistent with cruise stage separation in the Doppler. I'm showing a good strong signal, higher than expected carrier power, and continuing to see heartbeats. Medial comm tones look good. We are receiving heartbeat tones at this time. Things are looking good.
Sorry, I'm not talking very much and not reacting a lot, but
The entry RCS thrusters.
I can't take my eyes off of it, so
Cruise stage separation.
if this makes it, then that means that we're one step closer to manned missions to Mars.
In about 1 minute,
I want to see that.
software will wake up and begin final preparations for entry. The first action it'll take is to fire some warm-up pulses to get the entry RCS thrusters going. The pulses will ensure the spacecraft will get the thrust that we want when it's counting on it.
We did see the heartbeat signal drop low for a second as the signal passed by the donut of the cruise stage.
Alright, this is a very complicated landing. The atmosphere in Mars is 100 times lighter than Earth. Alright, yeah, it's saying velocity is 600 miles per hour. And still going up. Altitude control's taking lots of pictures. 685 miles per hour. Time to entry, 8 minutes. Time to touchdown, 15 minutes.
Could you check with the whether we should be seeing one-way data?
So speaking
Hey, is there copy?
in 1 minute, it should be already in the atmosphere.
Turning to entry.
Flight agents, we've been one way for a while now. Roger that. But currently we're just seeing the tones, obviously. Roger.
Everybody's
Vehicles
ate
reporting
peanuts
that
just
turning entry
to
rate's been down, and
pray
separated the cruise count
that
fast by
this goes well. They're lucky peanuts. Okay. Should be about time for
At this time,
official
the vehicle's
entry.
just sending heartbeat tones, just as we expect. It should be quiet for the next several minutes, hopefully. We are about 7 minutes to entry. At this time, Mars is actually pulling Curiosity in, and we're speeding up. We should be traveling around 5.4 kilometers per second on our way to about 5.9.
So, Rob, what are your thoughts at this point?
Well, I'm very excited in the pattern, antenna pattern.
I'm excited too. If you can't see me fidgeting with my nails.
This is where we're going to be at the top of the atmosphere. The great thing is that the propulsion system's shown to be working. We're turning the vehicle. It looks like the vehicle is going to be doing its entry job very well, and I'm very excited about that. Everything is going very well. So make sure everyone keeps their eyes on the television, because we might actually get some pictures, if all goes well, and we might be murky and covered with dust when we first land. But we might get some pictures today.
Wow. At landing.
Just a few minutes after landing.
Excellent. Okay, we're standing by.
Thank you.
Alright, I'm going to get a quick drink of water. But this is still recording and water's over here, so you'll see me.
We're just under 6 minutes to entry. We're continuing to wait for entry interface. The spacecraft is continuing to send heartbeat tones from the
We're coming up on the 7 minutes of terror. In other words, the 7 minutes while they're in orbit, well, in the atmosphere where we won't be able to communicate. Or rather, they won't be able to communicate with us.
We're now 5 minutes to entry. Continue to receive heartbeat tones.
Alright, so in 5 minutes, we're not going to know anything for another 7. That's the 7 minutes of terror.
So what's taking place now?
So right now the vehicle's flying through space. It's actually in deep space still. In fact, not until after we hit the entry point where we actually begin to feel the force of the atmosphere gradually building on that heat shield. So really it's still a spacecraft. It hasn't actually become an aircraft. But we checked out its rockets. It's actually used to turn the vehicle. It's turned to the right attitude. And that means
velocity 12,375 miles per hour.
It'll start doing its role.
Still rising.
The turn is part of the guidance that it does. It starts off with a right bank,
altitude 441 miles
and then make another
and
right
falling.
Makes its way to the landing site.
So it's a capsule right now.
It's a capsule. It's just a bare capsule. Nothing looking out. Just the radios.
Entry interface point. T minus 3 minutes and 50 seconds. 45 seconds as of mark.
Actually, just after entry, just before parachute opens up.
EDL phase dynamics.
Did that work out?
Go ahead, dynamics.
Just FYI, OD227 runout looks like missed distance of 232 meters. Over.
232 meters.
That's correct. Less than the divert.
Roger.
Alright, as it's coming into the atmosphere, it's going to have its heat shield represented by this hand. And it'll be coming down, and then at a short point after that, it'll bust off the heat shield. And then imagine this is the inside of the capsule. It's going to release the rover in its enclosure. The enclosure has boosters on it. So on top of the rover, the enclosure that's on top of that is going to lower it down by rope while keeping the boosters up so that it doesn't crash. And then once it's actually safely touched down, it's going to cut the ropes and fly away. If it doesn't do that, it's going to blow up a lot of dirt, which could mess with all of the systems. So, alright, so 1, 2, 3, 4. So it's 4 points, not counting the space travel over here in the first place.
Which is using the latest nav, our best guess of where we are, show us that the best guess of our landing.
Entry interface point, T minus 1 minute and 40 seconds as of
landing target. So,
now.
Looking good so far. We're continuing to receive heartbeat tones. Everything looks good. We're about 90
Altitude just under 200 miles. Velocity 12,850, still rising.
That last solution was with 227 or OD228.
That is OD227.
Thank you. You guys have now OD228 in your possession?
Just so you know, a lot of this stuff, I love science.
There will be no 228 for us.
And I'll study it. But a lot of this terminology that they're using, I don't know what it means.
In spitting distance.
But,
Affirmative.
yeah, just watching this and getting reactions.
Switching antenna shortly. We'll have a short dropout when that occurs in the tones. Switching to a tilted antenna that will be used through entry.
This is being monitored from California. California Institute of Technology. Their control room is filled with people. Mostly staff, but quite a few photographers. Alright.
We're switching the GLG.
13,000 miles per hour and still climbing. Less than 95 miles. 5, 4, 3, 2, 1. Okay, they're in the atmosphere, according to this.
Vehicle records entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system.
Alright, guidance will start in T-minus 20 seconds. Now. Alright. It's showing a different simulation now. The other one was also a simulation. They can't do real telemetry at the moment. They're doing all of this via pulses that they're getting. Pulses of information.
The engine atmosphere in the group. We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry.
Alright, pretty quick here, we're going to start the 7 minutes of terror. I seriously hope my internet doesn't cut out on me.
At this time, the vehicle is needing to steer its way to the target. It's starting its first tank reversal. First tank reversal complete. We have seen peak deceleration. We've passed through peak heating and peak deceleration. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's.
Flight GDSA.
GDSA flight go.
We are processing data from Odyssey.
Tank reversal 2 is starting. We are now getting telemetry from Odyssey. Tank reversal 2 complete.
Alright, they're getting telemetry from Odyssey.
Copy, tank reversal 2 complete.
Odyssey being the spacecraft that it went
Standby
in.
flight. We have a connection, but we actually do not have any data yet.
Copy. We can expect some intermittent contact at this time as the signal gets increases to respectable levels.
There we go. We are now seeing telemetry from RCDP.
Alright, starting to get telemetry.
Visualization is updated. We've entered heading alignment. Very good! At this time, Curiosity is no longer
I wish they'd show it.
how far it's flying down range. It's just heading directly
Okay. Mach 3.8.
minus 1.2 kilometers. Minus 1.2.
Velocity is about 900 miles a second. Well, meters a
The
second.
team is reporting that that things look pretty good at the end of range control. We have converged a lot of the error, and we should be heading for the target.
Now, after it lands,
Flight EDL.
it's not going to be able to send data directly.
Copy. Power
It's
on.
going to take maybe a few minutes.
Tone from indicating that we
So,
have seen heat
it's going to be kind of
through the MEP
icky.
engagement. Everything was fine. This is as expected. During this heading alignment phase, we're flying almost horizontally like a plane.
Fuel is 391.3 kilograms.
We're going about Mach 2.4 at an altitude of 17 kilometers or so.
Alright. So the chute is out. Altitude of 17 point something other kilometers.
Indicating that everything is fine during heading alignments. We are standing by for straighten up and fly right and parachute deploy.
Straighten up and fly right is where the boosters will actually keep it
We're down to
up.
about Mach 2. As a reminder, we should have parachute deploy around Mach 1.7.
Parachute hasn't deployed
We're at
yet.
15 kilometers altitude.
We've begun entry balance mass jettison. Predicted
Stand by for parachute deploy.
downrange is 1.597 kilometers. EDL ops, Odyssey Systems on EDL ops.
I always pop my knuckles. It's not a nervous habit, it's just a habit.
Parachute
Alright, so the parachute's out.
Thrusters have been re-enabled. We will control our attitude on shoot.
Alright, Mach 0.8.
Wrist mode under parachute.
Descending, we're at 150 meters per second.
Dynamics phase. Come back again with wrist mode dynamics. Wrist mode is nominal.
We're at 9 kilometers and descending.
Lead active. Valid range. Net filter to diverge with a velocity correction of 0.7 meters a second.
We've acquired the ground with the radar.
Altitude of 8 kilometers.
Heat shield has separated where we found the ground.
Alright, heat shielding's busted off.
We're using by to prime the Emily engines in preparation for power flight.
So,
We're down to 90 meters per second at an altitude of 6.5 kilometers descending.
alright, it's giving a stick figure almost simulation.
It is in battle short mode, so it should power
Just
itself.
based on data that they've got.
Okay, we've lost it already.
Alright,
We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
Ground solution equals minus 10.8 meters. Vertical velocity of minus 80.
We are climbing 8 meters per second. Start enabled. Standing by for batch separation.
Signals Odyssey is still strong.
We are in powered flight.
okay. They're using the boosters now. The boosters are supposed to keep it from coming down too fast
About 70 meters per second.
because the gravity, no, not the gravity, the atmosphere is so much thinner than Earth
Meters in altitude.
that they need something to slow it down. So the boosters are
Standing by for
pushing. They're pushing up
Constant velocity accordion.
while it's still
nominal.
falling
Altitude error
to help
5.9
slow it.
meters.
We found a nice flat place. We're coming in ready for Skycrane.
Alright, and here's where it comes down on the
Down 10
Skycrane.
meters per second. 40 meters altitude. Skycrane has started. Descending at about 0.75 meters per second as expected. Expecting throttle cut shortly.
Signal Odyssey remains strong.
Tango Delta nominal.
Yeah. You go calm. Configure view stable. Your view stable.
VHF is good. Touchdown confirmed. We're seeing.
Okay. Now here's where it's landed, but they haven't got any data yet.
Curiosity will take us.
This is where it's officially landed. They don't know whether or not it's safe yet, I don't think. They have to start receiving data from Mars to be able to know that it's safe. They're all giving congratulatory hugs now.
We're continuing to receive telemetry from Curiosity. We're safe.
And they said that they're receiving telemetry.
Takes off, waiting for images. Heads up, folks!
It's safe.
PL ops, signal to Odyssey remains strong.
Nice.
Images are starting to come down. We're beginning to get images. We got images coming down, folks.
Alright, images. Want to see images.
Thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
Odyssey's nice and high in the sky.
Want to see images?
Thumbnails are complete. You got thumbnails.
Alright. Looks like it's gray at the moment. Gray images.
It's the real. It's the real.
Bottom right hand corner, you can see the wheel of it. So essentially, if this is the wheel that it took a picture of, the camera's up here.
Keep watching, guys. Keep watching the stream. There's more stuff. Any minute now. No. 2:56.
Okay, okay. So here we are. We're going to start. Go ahead.
Okay.
So we have landed out at the time we thought we would, and we now have our first image.
We have our first image. This we've got is a 64 by 64 thumbnail. The front, a rear has-cam image. You can see the shadow there. I'm not sure exactly which our orientation is of the vehicle, but we're looking through it. I think in just a few minutes we might get even a larger 250 to 256 frame pixel image of that same end. So we're looking at the shadow. See, the horizon is actually in the distance. You can't really tell that. So we're looking actually at the shadow of this late afternoon sun.
So these are the rear has cams.
The rear has cams.
And it does have a dust cover on it.
It does have a dust cover, but it's the dust that covers the problem. It's the fact there's dust in the air because we've just blown dust all over the place with our descent engines.
Fantastic. So there could be more.
There could be more.
More, I want more.
If we wait, we might get, oh yeah! This is the high-res, this is the 256 by 256 image. This is the higher res. You're seeing dust particles on the window. You can see the horizon there in the background. And there is the wheel of the rover safely on the surface of Mars. I can't believe it. This is unbelievable. We might get another one of these, and if we're lucky, before Odyssey goes away, we'll get 2 more of these same images going the other side of the vehicle, and also probably dusty. This is amazing.
Alright, so they're saying it's one of the rear-facing cameras.
So that is one of Curiosity's rover wheels
Exactly.
on the surface of Mars.
Yes. Oh wow! Now we have another image coming down. This is a view looking the other direction. It's still being processed. We'll see it in just a second here. This is another thumbnail image.
Is that a shadow?
That's the shadow
Of the rover.
Curiosity rover on the surface of Mars. Thank you.
The Odyssey transition is about to end. It's about to set below the peak of Mount Sharp very shortly. So this is about all the data we're going to get, but things look great.
Yes.
Thank you.
I so want to see what Mars looks like. These pictures are just kind of gray. So you can't tell very much yet. Wow, there's a lot of dust on the cameras. Might have something to do with it being gray. Maybe. Alright, everybody's celebrating, everybody's hugging. Looked like for a second there 2 people were arm wrestling, but they were actually just clasping hands. Come on. We were playing with the paper doll of somebody. Alright, so if I'm not mistaken, they really won't be able to get too much more data today. So, more data to come tomorrow after they've finished reconnecting with the Odyssey. I think that's the name of it, Odyssey, or maybe. If I'm not, please forgive me. But no, they need to reconnect. It's going out of view, so the planet Mars is in the way. It didn't really happen, but it's kind of like the celebration they probably had when Johnny Cochran first got Warp Drive. Sorry for the Star Trek plug. But anyway, that is the end of my reaction video. Now to post it.